Hey guys, I wanted to make a quick video to differentiate these four network devices: a hub, switch, and bridge, and a router. I've seen, I personally confuse many of these devices, and now that I have a better understanding where are they used and how actually they work within an example, I thought I'm going to make a video to actually illustrate this. How about we quickly jump into it and show some examples? All right, how about we start with the hub? And what we're looking at here is our four devices here, and I'm only showing the MAC addresses. I'm not really showing the IP addresses because it's irrelevant at this configuration, but there is always obviously an IP address here. So these are the MAC addresses: A, C, D, B. Okay, and there is a hub, and the hub is basically these machines are connected to the hub through different ports, right? And the hub's job is when a certain signal comes to a certain port, it will just basically broadcast this to all ports. Very simple. So let's say I'm sending a frame that is destined to machine C, to the MAC address C, from MAC address A. So A is sending a frame to C. And you might say, Hussein, how are we sending frames? Since when I send frames to MAC addresses, I never do this as a user, as an engineer, I never send MAC addresses. Well, you don't really send frames, but technically for example, you're sending a GET request, and that GET request is in layer 7, and that layer 7 has, you specify the IP address, right? And when that packet goes all the way to layer 4, it adds the port and the source port, and then goes to layer 3, it adds the IP address, the destination IP of machine C, and then the source IP of U, which is A, and then all the way it goes to layer 2. Now it has to add the MAC address, because at layer 2 we only deal with MAC address, and that's when we do our address resolution protocol to find out what's the MAC address of this IP address, and it finds out that, oh, it's C. Okay, I'm not going to go through the details, but that's essentially, that's what we're talking about. We're talking about layer 2 here. So A wants to send a frame to C. The frame goes to the hub. The hub take a look and says, I'm not smart enough. I don't need I don't know what's this. I will basically broadcast it to all other ports. So that frame, despite it being destined just to C, D gets it, B gets it, and C gets it. Yikesy, very yikesy. So C basically will accept it because the destination MAC address is itself. D will says, meh, that's not me, I'm gonna drop it. B will says, meh, that's not me, I'm gonna drop it. Okay, unless they are in promiscuous mode, which in this case they are essentially sniffing the frame. So that's the hub. Hub is almost never used these days, but it's always good to understand what and they are not used obviously because of the inefficiency that we're talking about, right? It's just broadcasting, so the network becomes very busy for unnecessarily, right? You're making B and D drops your stinking frames. Why are you sending it to begin with, right? So let's go to the switch. A switch is a little bit smarter. So we have the same configuration here: A, C, D, B. I don't know why I started with C, D, B. As A, B, C, D. Okay, right? And then A is connected to the switch, B is connected to the switch, and D and C as well. These are different distinct ports. Okay, so when A wants to send a frame to C, the frame will go to this port, but the switch will say, aha, switches will actually look at the content. This is something the hub doesn't do, right? The switch will actually look and says, oh, let me parse it, and we'll look, oh, the destination MAC address is C. And last time I checked, there was someone named C connected to me on this particular port, so I'm gonna send it. So as a result, we only send the frame to C. Very efficient, right? So the switching actually does the switching of the frames, and it only delivers to the destined. So the switch is also smart enough. It will record the MAC addresses as it arrives and goes through the machine. So now the switch, now that A sends something to the switch knows that A is actually on this port. It remembers that fact, so it keeps some sort of a table in its device, and it looks up that table. Very efficient stuff. Switch is very, very efficient. All right, let's talk about a bridge. A bridge is really nothing but a smart device that connects two networks together as if you're connecting it with a wire. but a little bit smarter than just that. Okay, and I included this network now with hubs because it just illustrates better than an actual switch, because switch just almost makes the bridge useless in this situation for illustration purposes. So let's say you have a device A and device B, and they are connected to its own little bit in the network here, and C and D, they are also connected to their own little small network, and you want to make these visible to each other. You want all of the 4 machines to get the same subnet. They become the same subnet IP addresses, essentially, so that they can talk to each other, right? So if you want to do that, you can use a bridge. It will have knowledge that, oh, C is actually on this side, D is actually on this side, A is actually on this side, B is actually on this side. That's the knowledge it has, right? So if A want to send a message to B, if the bridge gets it, it says, what are you doing? B is actually on your side. I'm not gonna send it to my other side, right? And if C want to send a message to D, and the bridge gets it and says, what are you doing? C, you don't have to send me anything. I'm gonna filter out the message here. Okay, that's what the bridge is. But if C want to talk to A, the bridge will say, oh, okay, actually A is on the other side. Sometimes the bridge actually doesn't know that, so it has to test. So yeah, that's the value of a bridge. And bridge being wireless is really, really powerful, especially if you have like a bridge access point here, another bridge access point here, and then you just treat it as a bridge, right? They connect it to either, they secure the connection wireless, right? Encrypt and whatnot. And then if you send anything to this particular point of the bridge, it will just bridge it to the other side. Okay, and that's how the wireless bridging works. Very powerful stuff. Yet these guys will become essentially in one network. So the IP addresses, essentially, they are almost the same subnet, because the bridge is nothing. Again, think of it like a wire. You're just connecting the wire, but it is smarter because it doesn't just randomly send packets. It knows, it keeps track of what frames, almost like a switch. If I'm going to compare the bridge to the switch, I would say the bridge just have a general knowledge. The bridge knows, hey, C is on this side, D is on this side, E on this side, K is on this side. That's it. It doesn't really know which part or which path. It just says, hey, it's there. I know it's there. Just send it. The switch, if C and D and E and F connected to the switch is so efficient that it's just only gonna send it to C. So let's take the final example, a router. A router really plays at layer 3. All the devices that we talked here, the switch, the hub is not even layer 3. The hub is layer 1, really. It just literally works at the signal level. It's just dumb. It doesn't look at the content. Switch is layer 2 because it looks at frames, right, which is layer 2. Bridge is definitely layer 2 because it looks at the frames, it looks at the MAC addresses. But routers is really both layer 2 and 3. It looks at layer 2 and also looks at layer 3 because it looks at the IP addresses. That's what it routes packets, IP packets, not frames, deals with packets. So if you are connecting 2 different networks, which we have now, we have this big one network, and look at, I use the bridge here again, okay, because these guys are really one network, and I just happen to bridge them. I could bridge them wirelessly, I could bridge them wired, doesn't matter, right? This could be part of a Docker container, right? These could be Docker containers for all we care, and they are bridged to the local host, right? So they are essentially virtualized. You can do all this kind of stuff. That's where bridge really is useful, with virtualization most of the time. So what do we have here? We have a router with 2 interfaces here. Their interface, the gateway is 10.0.0.1. The other interface, this is the gateway 192.168.1.1, or this could be the entire WAN, the actual internet, right? So there's 2 networks here, 2 different IP addresses. So if I'm connected to here and the router is DHCP, all of those puppies get IP addresses based on the DHCP, which is 10.0.0.1 gateway, right? So now 10.0.0.2, if I want to send, let's go through example. Let's say I'm going to send a frame. D want to send a frame to C. So D to C, that's a local layer 2 transport, right? So we're transporting D immediately to C, the switch is smart. It knows, oh, C is actually this side. I don't even need to go to the bridge or router. It's a local transport. It's very efficient sending D to C. Okay. All right. Let's say I want to send D to A. Well, same thing. D goes to here. D knows that, okay, switch knows that A is somewhere on this bridge, definitely not here. Okay, it goes right here. So the switch knows that A is actually on this side because the network has aged enough for the table on the switch and the bridge and these switches to actually update, to have that knowledge that A is actually on this side. So A will be sent, the frame will be sent here. The bridge is smart enough. Okay, yeah, A is actually on this side. We'll send it to the switch. Oh, this side. Okay, want to go to A. A is actually on this particular port, and we'll send it to A directly. So now let's say I want to send a packet this time. I want to send a packet from D, which is 10.0.0.2. I have no idea of frames now. We're just dealing with IP addresses at layer 3, right? 10.0.0.2. Now, let's spice things up a little bit. Now, I want to go all the way to another network. 10.0.0.2 want to send a packet to 192.168.1.2. That's where it gets spicy. Now, 10.0.0.2, immediately when you want to send a packet to a different network, the device says, well, this guy is not even in my subnet. This is 192.168.1 and 2. This is not my subnet. It applies the subnet mask and says, hey, this is not in my network at all. Hey, gateway, deal with this. So all of a sudden, the packet will be sent destined to 192.168.1.2, but the frame destination MAC address is the router MAC address in this case, which is R. So now, why this is all because I got the gateway. I have configured the gateway right here on this machine, and I found the MAC address of the router of the gateway, and now I send it all the way. The router gets it. The router looks at the frame, says, yes, this is destined to me. That's the frame destined to me as R. But look at me, let me look at the IP packet. It looks at the IP packet, says, oh, 192.168.1.2. Oh, that's not me, right? Because this is definitely going to go to an IP address, but I know how to get there. I definitely know how to get there, right? So what happens here is the router, again, the source IP address is 10.0.0.2 and the destination is 192.168.192. So now the router does a little bit of something called NAT, network address translation, and translates says, okay, in order to send this guy the packet, I need to change the IP address from 10.0.0.2 to, I need to route from 10.0.0.2 to masquerade it as myself, 192.168.1, and I'm gonna keep track. Oh, that 10.0.0.2 actually wants something sent to this device. So now, router does a question. Where is 192.168.1.2? Well, I have to do an ARP. So it does an ARP and finds the MAC address of this, and then it finds out the MAC address and now sends the MAC address all of a sudden to this, right? And now, you don't see it, but it's actually different ports here. I should have moved this a little bit, maybe, huh? Okay, fixed. So this is different port. So now that the router knows the MAC address, it will just immediately knows what port, because the router technically is also a switch. It is smart. Most routers are actually switches, right? And let's say this is Ethernet connected wires. So router knows that X is actually on this port, not this port. So it's only gonna send it to this guy, and it's gonna receive it. And X, once done, is gonna respond back to whom? No, it's not gonna respond to 10.0.0.2. It doesn't know 10.0.0.2. It knows the router, so it's gonna send it back to the router. The router will do retranslation of the NAT and will send it back to 10.0.0.2. Okay, essentially it does the same exact thing through this interface. So that's the difference between a hub, a switch, a bridge, and a router. Hope you guys enjoyed this video. I know it was a little bit long, but usually when you want to explain things with examples, it takes time because there are so many intricacies to explain all these different things, right? All right, guys, I'm gonna see you in the next one. You guys stay awesome. Goodbye.